All right, welcome back everyone. We are going to start lesson 4.7, solving using the quadratic equation. Just to recap our previous methods of solving, we learned how to factor and solve using the zero product property, setting each factor equal to 0 and solving. We learned how to complete the square and solve using square roots by undoing. If something would not be factorable, that would be an alternative approach. However, things can get a little bit messy in the solving using completing the square method if the a value is not equal to 1. All right. So if that's not your preference, this is an alternative to doing that. All right. You can solve using the quadratic formula. How do we get the quadratic formula? Well, it comes from the standard form of a quadratic equation, okay, which is ax squared plus bx plus c. In order to solve for any x-intercept, okay, our directions are setting y equals 0 and solving for x. So that equation is being set to 0, just like we did for factoring, zero product property. All right. Now, the quadratic formula is listed below. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. All right. So the coefficient of our x squared term, okay, is where a comes from. The coefficient of our linear term, b, is where that comes from. And then our constant term is c, and that's where we plug in there. All right, I learned this formula a long time ago, who I thought was from my crazy algebra teacher. She sang this song to us to the tune of Pop Goes the Weasel. Very strange. However, I still remember it, and I sing that song every time I use this. And I'll never forget it. It was cheesy, it was corny, but cheesy works. Okay, so let me just sing it one time for you guys, and you may like to use it. All right, so here it goes. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So again, cheesy works. You might not like it, but it works. So good luck trying to get that little song out of your head here tonight. Now let's apply this formula. All right. So directions are asking us to apply the quadratic formula to solve the following equations. So the first thing I'd like to do is identify my a, my b, and my c. That way I know what to plug in. Okay, so when there is no coefficient, it's 1. So that's my a, that's my b, that's my c. So a equals 1, b equals 6, c equals 5. Now we just substitute and evaluate. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. I would say the hardest calculation to get right is this one right here that I highlighted. That's called the discriminant. It's under the radical. When b is negative, people don't type that in, the negative in parentheses before they square it. I like to jam all that in one shot if you can't do it mentally. So type that in. You should get 16 divided by 2. In this case, the square root of 16 is perfectly 4. And then we can split this. I can do my addition over here, my subtraction here. So negative 6 plus 4 divided by 2, that's negative 2 over 2, which is negative 1. And then negative 6 minus 4 is negative 10. Negative 10 divided by 2 is negative 5. Okay, so my two x-intercepts are at negative 1, 0 and negative 5, 0. All right. Now some of you might be saying, well, why did you even use the quadratic formula? Why couldn't we have just factored that? And you're right, we could have factored it. Okay, we could have factored into x plus 1, x plus 5, and applied the zero product property here to get your negative 1 and your negative 5. All right, but sometimes things aren't recognizable, or maybe you just don't see the combination to make it true. quadratic formula will always yield you the solution of your quadratic equation. Okay. The second one I'm going to make down here, all right, and we'll do this in using the quadratic formula as well. So a is 2, b is 3, c is -9. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay. Once again, my recommendation is typing all that in with parentheses. Another area of confusion is the negative. Okay, this is a -4 times a -9 in there. That turns to a plus. Some people keep it a minus. It's a mess. Okay, so just type it in. 3 squared minus 4 times 2 times -9. And we get 81. Square root of 81 is 9. And then we can split this up, do the addition, do the subtraction. So that would be 6 over 4, which is 1.5. And -3 minus 9 is -12 over 4, which is -3. All right. I think I actually have this one on the graph where we can confirm these x-intercepts. So using Desmos, again, this is the graphing tool that we currently have. If I go back to that, there's our equation, 2x squared plus 3x minus 9, and we can see if we touch those points, -3, 0, and 1.50 are confirmed as x-intercepts. Once again, some of you may be saying, well, those are nice numbers. Couldn't have I factored that and used zero product property? Yes, you could have. But sometimes when you have larger numbers, especially your a values, a coefficient other than 1, you might not want to go through even, trying factoring as a valid approach. Quadratic formula will get you there. Other people who are automatic with factoring are going to get there quicker and more efficiently. However, this gets you there as well. Okay. Let's try a couple more. Okay. This is just definition of finding x and y intercepts. That's been set since Algebra 1. It'll never change. And then we don't have a Socrative quiz for you to take, so just ignore those directions. Another video here. Just like the previous lesson, there was an extra video in case you needed more help or another point of view. I don't understand, how another point of view, the quadratic formula is what it is. You plug and chug, spit out your answers. Okay. All right, so finding x and y intercepts here. We look at the first one, x squared plus 4x minus 8. Okay. X squared plus 4x minus 8. All right. Let's identify A, B, and C. So A is 1, B is 4, C is -8. X equals -b plus or minus the square root b squared minus 4ac all over 2a. So if we crunch our discriminant, 4 squared minus 4 times 1 times -8, we get 48, all divided by 2. Now here we don't have a perfect square. So off to the side, we're going to have to simplify the square root of 48. Okay, so what largest perfect square is hiding in a 48? 16, so 16 times 3. Square root of 16 is 4. So this is -4 plus or minus 4 root 3 over 2. And then we could simplify this further because each of these factors divides by 2. So x equals -2 plus or minus 2 root 3. Okay, that would be the exact form of our answer there. If directions ask you for leave your answer in exact form, there it is. There's our two answers, plus or minus. You could also confirm you know, estimate or approximate the decimal, type in -2 plus 2 root 3, get your decimal, -2 minus 2 root 3, get the decimal, confirm that graphically as well. Okay, I want you guys to try this one here, y equals 2x squared minus 8x plus 7. Okay, give that one a try, 2x squared minus 8x plus 7. Again, you can pause it and go from there. I'm going to go through the solution to that one really quick. I'm going to squeeze it in here. Now here's a situation where b is already negative. So some people don't like doing minus a -8. Well, that's just going to turn to plus a positive anyway. So if you know that already, you don't want to go through the hoops of minus, negative, plus positive. Some people consider that opposite x equals -b. They say the opposite of b. Okay, it all means the same thing. So the opposite of -8 is +8. Again, make sure when you punch this in, b squared, make sure that -8 is in parentheses before you square it. We have to simplify this radical, the square root of 8, square root of 4 times square root of 2, so that's 2 root 2. So x equals 8 plus or minus 2 root 2 over 4. Some people like to leave it like that. Others are going to simplify this. 8 divided by 4 is 2. And then 2 divided by 4 right here is 1/2. So they would say root 2 over 2. Okay. All right. Let's try 2 more. Again, you can pause the video at any time. I have 2 more questions here, and then we're going to wrap this up. All right. So write down 3x squared plus 5x minus 1. Identify your a, b, and c. Plug correctly into the quadratic formula. And evaluate. Simple as that. So this would be the exact form. It's a question answer for the exact answer. It's not a decimal approximation. However, like I mentioned before, it'd be nice to confirm the decimal to know that that exact answer is correct. 37 cannot be, simplified with radicals. That's a prime number. So there's no perfect squares hiding in that. So what I'm going to do, I'm just going to type in 5 plus the square root of 37 divided by 6, and then 5 minus the square root of 37 divided by 6, being sure to hit enter after I do the 37. So the numerator is calculated, then I'm dividing by 6. So I get, what's a -5? Negative b. So -5 plus the square root of 37, enter, divided by 6, I get 0.18. And -5 minus the square root of 37, enter, divided by 6, -1.847. Okay. So these two answers here are, in fact, your x-intercepts, approximately. Okay. Again, they're rounded answers. So if you want to confirm that, again, I have the last two here on Desmos. So if we go back to Desmos, 3x squared plus 5x minus 1, let's highlight that equation, touch on the x-intercepts, and there they are. Okay, one more to go. All right, 2x squared minus 8x plus 3. Get this one right. Identify A, B, and C according to our coefficients of our quadratic and standard form. Now we plug into the quadratic formula. X equals negative b, or the opposite of b, plus or minus the square root, b squared minus 4ac, all over 2a. Negative 8 quantity squared minus 4 times 2 times 3. Square root of 40. All divided by 4. If it's asking for the simplified exact solution, the square root of 40 can be simplified. Whoops. Square root of 40 can be simplified. The square root of 4 times the square root of 10, so that'd be 2 root 10. And then clean up. 8 divided by 4 is 2. And then 2/4 is a half. So plus or minus root 10 over 2. All right. If you're not simplifying it in exact form, you could just type in from this line up here, 8 plus the square root of 40, enter, divide by 4, 8 minus the square root of 40, enter, divide by 4 to get your decimals, okay? So I'm going to do that. I'm just going to type in, doesn't matter where, your final answer that's boxed or what's highlighted in green, doesn't matter. We should yield the same solutions, and then we will confirm them on the graph. So one of those solutions, the addition, gives you 3.581, and the subtraction gives us 0.4188, so we're going to round that to 0.419. And these would be your x-intercepts approximately due to rounding. So let's go check those in orange on the graph and see if we got it right. .419, 3.581. Okay. And there they are. Okay, so that concludes our quick lesson here on the quadratic formula. Remember, just to recap, get your quadratic equation equal to 0, pull out your a, b, and c, and then substitute into the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. All right, so then we execute that, spit out your answers, and then as always, we can confirm those x-intercepts graphically. All right. Thanks a lot, guys.